All of us get excited when we see the symbol. But how does it work? Ever wondered how millions of subscribers are served by telecom operators simultaneously? Hi everyone. Welcome to the world of long-term evolution. Today we will show how multiple users access network using multiplexing.
In the last video we have shown how two signals were combined over a common pathway in duplexing. So, what exactly is multiplexing? Multiplexing is the process of combining multiple signals and transmitting them over a common channel. Then what is multiple access? When multiplexing is used to allow multiple users to communicate over a single common channel, we call it multiple access. In other words, multiple access is nothing but the application of multiplexing. So here's a Wi-Fi hotspot sharing its internet connection among multiple users by providing them a frequency block over which they can transmit and receive data. The greater the size of this block, greater is the throughput. Telecommunication systems, which mostly use radio waves as a communication link with end users, have employed several ways to share this resource.
FDMA, which uses frequency division multiplexing, provides chunks of the frequency spectrum to each user for data transmission. Generally, the data is generated at baseband and modulated at varying radio frequencies. Guard bands are introduced to avoid any interference. AMPS or the first generation analog systems used FDMA to provide each user a duplex channel with one-way bandwidth of 30 kHz. TDMA, which uses time division multiplexing, allows multiple users to share a common frequency band by allocating different time slots. Thus, in an N-channel TDMA, where each channel is given a time slot of 2 seconds, signals coming from each user will be transmitted at intervals of N into T seconds. This technology was used in the 2G systems like GSM, GPRS and EDGE. Each user was provided one of 8 TDMA slots and a bandwidth of 200 kHz. Dynamic resource allocation meant more users could be supported, but each channel could support only 8 active users at a time. CDMA, based on code division multiplexing, is a technique in which the data bits are modulated by a high-frequency orthogonal sequence of bits such as Walsh codes or pseudo-random codes such as gold codes to spread the signals over a large frequency band. Multiple such signals from different users are then transmitted over the same frequency band. In order to retrieve the signal, receiver must have the same spreading sequence, which is multiplied to this composite signal in a process called despreading. This makes CDMA very secure and robust. It was used in 3GPP2 standards such as CDMA and CDMA Evolution Data Optimized standards. Wideband CDMA or WCDMA spreads the signals over an even higher bandwidth. This was used in the 3G standards of 3GPP from UMTS to HSPA+, where the available bandwidth was 5 MHz compared to 1.25 MHz used in CDMA. There are other multiple access techniques like wavelength division multiple access, which is used in fiber optics, and space division multiple access, which refers to spectrum reuse over non-overlapping areas.
As the number of users and their demand started growing, communication networks evolved from 1G to 4G. Radio part was significantly enhanced from GSM to HSPA+. Now, focus was shifted towards better spectral efficiency by using higher modulation order like QPSK, 8PSK, 16COM, 64COM, etc. WCDMA improved upon some of the problems of earlier generations like, first, low data rates. In GSM, effective bandwidth for a user was only 25 kHz. Second, congestion at peak hours, as the frequency chunks and time slots were very limited. Third, resource wastage, resources remained idle when users were inactive. Fourth, poor spectral efficiency, due to guard bands and guard periods used for avoid interference. But, exhaustion of spectrum, need for even higher data rates, and spectral efficiency lead us towards OFDMA. OFDMA comes with several advantages over WCDMA like bandwidth scalability, carrier aggregation, low intersymbol interference. OFDMA uses orthogonal subcarriers equally spaced at 15 kHz. Users are provided a subset of these subcarriers for data transmission. Unlike FDMA or TDMA, OFDMA allows the users to access variable bandwidth depending upon the resource availability. Also, since these subcarriers are orthogonal, there are no guard bands between them. It was first introduced in Wi-Fi, and subsequently in WiMAX, by IEEE, but as WiMAX lacked backward compatibility and support for mobile wireless at its inception, operators remained stuck with CDMA. This changed with the introduction of LTE, which brought OFDMA to the forefront of today's mobile networks.
So, today we showed what were the different multiple access techniques that were used in various generations of wireless communication. In our next video, we will dive deep into OFDMA and FDMA, the two pillars of 4G. Hope you enjoyed the video. Don't forget to subscribe to our channel to stay updated. Happy learning!